So in this circuit, we have a 12-volt battery powering a light bulb, and we inserted this variable resistor so that we can control the current and PD across the light bulb. Let's start with the minimum PD across the light bulb. If we want the minimum PD, we should push the tapping point all the way down here. The idea is we want the battery to have to push currents through the entire 10 ohms. So the battery is seeing the maximum possible resistance, so it will be pumping out the least possible current, which will result in a smallest PD across the light bulb. So you see now that what we are having is actually 12 volts that must be shared between the light bulb and the 10 ohm resistance. So the PD that will appear across the terminals of this light bulb is going to be R divided by the total resistance, which is R plus 10 of 12 volts. So the problem is the resistance of the light bulb, which is R here, is also a few ohms, which is comparable to the 10 ohms here. So this ratio here will be nowhere near zero. You can imagine maybe this is 2 ohms, 2 divided by 12, you still end up with about 2 volts. So it's nowhere near zero. The problem is because these two resistances are too close. If this variable resistor has a maximum resistance of say 1 kilo ohms, then the minimum PD will be R divided by R plus 1000. So if R is just a few ohms, then you can see that we can push this ratio to very close to zero, and we can get practically 0 volts across the light bulb. But as it is, both of them are a few ohms, so it's not possible to reduce the PD to be near zero. Okay, what about the maximum PD across the light bulb? To get the maximum PD, we will tap the variable resistor at the top here. So we'll completely bypass the 10 ohms here. So as it is, you can see that the terminals of the light bulb is actually now directly connected to the terminals of the battery. So by right, we should be able to get 12 volts across the light bulb, provided that this battery has got no internal resistance. But suppose that it has. Let's call the internal resistance little r. If there's that little resistor there, then again the 12 volts have to be shared between the light bulb and the internal resistance. So the maximum PD is going to be R out of R plus little r of 12 volts. So supposing that the internal resistance is also a few ohms, then again we see that this ratio here cannot be pushed to very near 1. So it's not possible for us to get 12 volts across the light bulb. So it all depends on how the resistances compare to each other. For example, you can see that if this resistance is not 10 but a very large value, we should be able to get practically 0 volts. Likewise, if this internal resistance is very small compared to the resistance of the light bulb, we should be able to push the PD all the way to practically 12 volts. Okay, that's all I have to say. Ta-ta!